welcome to Facet AI again. And for today's tutorial, we'll go over a simple supervised fine-tuning SFT example for one of the smaller model, Gemma 270M. And I found this pretty cool dataset called Emotions dataset from Hugging Face Hub when I was browsing it. And let's just get started with it. Let's just get started with this one. So there is a whole bunch of sentences that got scraped, for example, from Twitter, and we're gonna teach your AI to classify a emotion that is expressed in this sentence. So we can go ahead and create our data set. This is pretty straightforward. There's only one available splits, but for some other samples, there might be more available splits. So for example, there might be a clean version and a non-clean, like a raw version. And in here is pretty simple. We're just gonna name it emotions dataset. This is a language modeling dataset, obviously. And for system message, we should put, for example, classify the following, the emotion expressed in the following sentence. And for user message, we're just going to map a column, which is the sentence column, and for a system message, the labels column. So you see that we can easily map data set that are in column format, in raw data formats to a conversational format that is very good for fine-tuning. And here we're not going to use the 131,000 sample. I think 4,000-ish is probably enough for a small model. So maybe a little bit more. Yeah, here we go. And then we're just going to wait for preprocessing to finish. Okay, that looks great. Let's look at some of our sample data. Here they are. You can see that they look pretty good, and it's time for training. To actually train a model, we're gonna go to select a model first with our unsloth provider, our emotions dataset that we just created, and for the job name, I'm just gonna call it emotion classification. And we are actually gonna do full fine-tuning here because since the model is pretty small, and instead of parameter efficient fine-tuning, and we're gonna use SFT trainer with text modality, and I might increase the batch size a little bit, reduce the epoch a little bit. And we're gonna use all the default settings for everything else, which is pretty much disable all the complex export evaluations, since we're gonna do it separately at the very end. So let's submit a training job. You will see it show up right here being queued. I have a lot of other jobs that I complete, and let's just wait for the job to finish. So now that our training job has completed, we're gonna go look at the training log, and we can also view the training log during the training, but in this case, the log looks pretty clean. Everything looks nice. Let's try to evaluate the model. And to evaluate the model, we can just come here, and we've turned on the compare model mode, so we can compare the base model that has been trained with the model that we have trained from this task. And next, we're gonna select evaluation mode. In this case, we're gonna use a metric-based evaluation, since this task is pretty easy to evaluate with metrics. We're not gonna use the task, but you will want to consider using a task if you're doing any translation, question answering, conversational tasks. But in this case, we kind of know what we're looking for, so we can just turn on metric-based approach and turn off the turn off the blue score and root score, and turn on accuracy and exact match. And with that being done, we can just configure the max sample to probably just run over 50-ish samples for each, and let's run evaluation. We also have to copy over the dataset ID for the base model, since we don't know which dataset the base model is not trained on any dataset, so we might want to copy it over. So here are the results, and of course exact match might not be the best metric. We're gonna look at the actual samples that are generated by the model later, but you can see that the base model basically got 0, and our model is slightly better, but this might not be the best benchmark for your use case. And in this case, it might just mismatch by like a few characters that a model generates or anything. And sometimes it's also beneficial to look at some sample that a model generated. You can also see it from metric-based evaluation, but I'm just gonna introduce another interface here, which you can run to see some samples that the model generated. We can load some sample, which is very similar to what happened with evaluation. Now that we have the dataset loaded, we're just gonna select a few sample here, and we can run the batch inference on both of these models. So let's give it a try. So here are the results generated by the model, and we can see a clear, huge difference after and before fine-tuning. So this is the base model on the left. It is completely not following our required structure format, and the first example is pretty much outputting gibberish. This is pure model output. This is not the question, so you can see that there is a huge difference. And if you actually look at a question here, obviously for the first question it should be outputting love, the second one happiness. So it might not be 100% accurate, but there's a huge improvement if you actually look at answers that are completely wrong on this side. So that's very nice. We're gonna wrap up here by running this model locally. So let's go to model exports. So here's the model exports page, and you can see that I already have a lot of export jobs here, and I'm gonna go to the model that I just trained for emotion classification. And for this one, I'm gonna export it as a GGUF file and run it locally using Ollama. And you can see that I've already exported this, but if I haven't, I can just select GGUF and the destination and start exporting. But I already have the file. I've done it before, so I'm just gonna download it here from GCS. You can also push it to Hub and with ID if you want to deploy this, like for example, on a cloud. And now let's just wait for this to download. So now we have the model exported. We're gonna pull up our terminal and run it with Ollama. And let's go to the downloads folder where we have the model.gguf and a model file. So the first step would just be to write the model file, which I have already done with a system prompt and the path to the GGUF file. And then we're going to use Ollama to create the model that we want from the model file, which I have also done. And then I'm just going to start Ollama and run this model that I have created. And now I can send a message. So I'm just going to ask something like, oh, how comes the AWS service is down again? I thought they told the AI to stop making mistakes in their code, which very sensibly is confusion. I am equally confused as the model. So let's end this example here. It shows how you can easily run this model locally if it's a very small one like 270M, and the improvement is huge that we've seen. So that's a great demo. I hope you enjoyed it. And in the next one, we'll probably go over how to deploy the model on cloud, for example, with VLM, with other types of exports, and look at different use cases. So stay tuned for next episode in the series.